Hi everyone, welcome back to Geeks for Geeks, and welcome back to another problem of the day as well. Please give me a +1 in the chat if my voice is clearly audible to everyone and everything is working fine. Then we'll start with this problem as well. Today's problem is quite interesting and it has been asked in Uber. It's rated as hard problem, but I would say it's a medium problem only. So you can give me a +1 in the chat if everything is working fine, and then we can go over to discuss the problem. So hi Vanshika, hi Naikaj, and hi Rishit as always. Let's share the screen and discuss the problem. So give me a second. I'm sharing my screen. You can let me know if it's visible or not. Okay, so I've shared my entire screen now, and let us start discussing this problem. So I hope everything is working fine as of now. Okay, so everything is working fine. What you have to do in this problem is you have to find the shortest path using at most one curved edge. Okay, so what you will be given is you will be given a weighted graph. Okay, let's say that when you're given a weighted graph, right? So what algorithm comes to your mind when you're given a weighted graph and you have to find the shortest path, right? You have to find the shortest path from a particular cell to another cell, right? From a particular node to another node. It says that you'll be given a undirected graph which will be kind of weighted in nature. Okay, so every edge will be having some weight. You can see here that this graph will be having some weight. So when a graph is having some weight and you are having a particular starting point and the ending point, you are having a source and you are having a destination. So can I say that you will apply the Dijkstra algorithm? Please write yes in the chat. Everyone is agreeing with me, right? So we will do what? We will apply the Dijkstra's algorithm, right? That is the whole point. Like we will apply the Dijkstra algorithm, right? We will apply the Dijkstra algorithm. Everyone is clear with this? I hope that everyone is clear. Please give me a +1 in the chat, right? In order to solve this problem, the very first thing is that if we want to find the shortest path in a weighted graph, then we will be using the Dijkstra algorithm. So this point is clear to everyone, right? So same thing here can be applied. Like what you can do is whatever graph has been given, right? So whatever graph has been given in form of edges, you can make the adjacency list of that graph, right? And after making the adjacency list, what you can do is you can apply the Dijkstra algorithm, right? And then when you apply the Dijkstra algorithm, so after that, whatever is the answer, that is the shortest path that you can get on this graph, right? But there is one more thing that has been given here. Like we will be doing that first, right? So that is one of the ways. One of the ways is that you can directly apply the Dijkstra algorithm, and let's say you start from A, right? So the distance of if you are starting from A, so it will be 0, right? And then you apply the Dijkstra algorithm. So in that case, whatever dB will be there, right, that will be the final answer. Is this point clear? This much point is clear to everyone. That will be the very first thing. This much point is clear. That what you can do is you will simply apply the Dijkstra algorithm in this graph in order to get the shortest path. So is this much point clear? This is one thing. But another thing is that there is some special kind of edge also given, right? Let's say there is some special kind of edge given. If you will see here, so there is some curved edge given. So what does this curved edge mean? Basically it says that, let's say you have a starting node, like so if you have this particular starting node, let's say as A, right? If you have the node as A, this is the starting point, and you have to reach B. Okay, so you can go through a wire path. You can do what? You can choose an edge between them. So what you can do is, let's say this is U and this is a node V. All right, so what you can do is you can reach from, like, let's say there are some other nodes also in between. Like let's say there is some graph in between, right? There is some graph in between. So what you can do is, let's say for reaching from A to B, let's say this is whole part is graph, right? And from V to B also there is a graph, like this is some intermediate graph, right? So what you can do is you can use this U to V edge, which will be like a curved edge. Okay, this will be like the curved edge. So what you can do is, first of all, from this edge A you can reach U. Okay, so the cost for that will be nothing but DAU. Like if I'll apply the Dijkstra algorithm, right, from A, then I will get the cost, the shortest path from for reaching starting from A, that will be, let's say, DAU using the Dijkstra algorithm. And similarly, if I will apply the Dijkstra algorithm for B, so the shortest path from B for reaching V will be DB, applying the Dijkstra from the node B. Okay, and passing this edge V. So basically the shortest path from B in order to reach V. So this will be the cost, right? So are you getting the point? That I can do what? Either I can directly say that overall I'll apply the Dijkstra algorithm, right? So starting from A as a source node, whatever will be the minimum cost for reaching B, that can be the answer. Or another answer can be that whatever intermediate edges, whatever special edges I am having, I can take them, right? So in that case, if I can follow a path that is from A to U, right, if there is a edge A, and I can take this U to V special edge, right? So what I can do is, first of all, I can find the cost of reaching from A to U, that I can do using the D, like if I'll apply the Dijkstra from A. So using DAU, I will get the minimum cost starting from A to reach the node U. Okay, so that will be the cost DAU plus DBV, that is the minimum cost starting from B, the minimum cost to reach V, plus the special edge, right? Plus this, the weight of this special edge. Is that clear to everyone? Please tell me, guys. This part is clear. That is one thing, that another thing that I can do. Is that clear? Please tell me, guys. If I want to reach from A to B, so what I can do is I can take the help of a special edge. So let's say there is some in between there is some graph. So first of all, I can like if U to V is a special edge, then what I can try to do is I can try to find the shortest path, the shortest cost, the minimum cost to in order to reach from A to U using the DAU. Okay. Similarly, the shortest path for starting from B to reach V, that will be DBV plus the special edge, plus this particular special edge that I will be traversing. Is that clear? But there is a possibility that we can reach the destination directly. Yes, there is definitely a possibility. That is what I said. That is why you can say that the very first possibility, that there are three possibilities, right? So the very first possibility is that if I don't take any path. So if let's say I start from A and I want to reach B, so I can directly apply the Dijkstra algorithm, that is starting from A, whatever is the cost in order to reach this particular B. That is the first thing that I can do. The second thing that I can do is I can reach through the wire path. So if I want to go from A to B, then in between I can cover this edge U to V, right? So first of all, I can go from A to U. Okay, then from I can use this edge U to V, that is the curved edge. Okay, so DAU will tell me the minimum cost in order to reach U, the node U starting from A. Okay, and similarly DBV will tell me the minimum cost to reach the node V starting if I start the Dijkstra from B, plus the weight of this special edge. So is this clear? Devansh Agarwal and other people are also clear? Please tell me, guys. Is this point clear to everyone? Right. Is it clear to all of us? Please tell me in the chat. If you're clear, please hit the like button, guys. Rishit is clear with it. What about the others? Devansh Agarwal is also clear with it. Okay, Ram Goel says yes. What about others? Right, there can be a third path also, right? The third scenario can be that if I am having this edge A, okay, and let's say this is V and this is U, and then you are having this as B. So what I can do is I can try like I can let's say there is some intermediate graph. So from A I can try to reach V through some graph, like let's say there is some graph in between, right? Then similarly from B I can try to reach U, let's say there is some graph in between, right, here and here, and then I can try to take this special curved edge, right, this particular edge. So in that case, the cost will be what? The cost will be nothing but DAV, that is the minimum cost, to reach the node V if I'm starting from A. So I'll apply the extra for that, starting from A, plus the special edge, right, plus this particular special edge weight, right, plus the plus this particular thing, plus DBU. That is the minimum cost to reach the node U if I'm starting the Dijkstra from B. Okay, if the source node is B. Is that clear? All of us are clear? Okay, Devrat is also saying he is clear. What about others? If everyone is clear, then please make sure to hit the like button, guys. Is it clear to everyone? If everyone is clear, so please hit the like button so that I can understand that all of you are clear with this particular example. So there is a possibility that we can reach from A to U and then U to B directly, and then so that will be taken care of by this particular thing, no? So that you can take care of by applying the direct Dijkstra algorithm, no? By applying the very first condition, that you can take care of. That will be taken care of internally only. That you will not have, in that case you will not have any special edge, no? So in that case, it will be nothing but DB like DAB. So basically the cost, the minimum cost to reach the cell B, the node B, if I'm starting the Dijkstra from A. So the shortest path in a weighted graph for reaching the node B if I'm starting the Dijkstra as the source node from A. So is that clear? Agarwal, is that clear? Devansh Agarwal? I hope that this point makes sense. First thing is that I can directly apply the Dijkstra algorithm, right? So that could be the answer. Or there can be a lot of internal scenarios that from A I can reach the node U. So starting from A, I can reach the node U by applying the Dijkstra minimum cost for that, plus the cost of this special edge that I'm having from U to V, and plus the cost that is from B to V. What is the cost? So dBV will be the cost. So I'll be starting another Dijkstra from V in order to calculate the cost for reaching the node V. Okay, that is the thing. Or the third scenario can be that what I can do is I can have A. Okay, A is there, V is there. So from A, I try to reach the node V. In between, there will be some graph that will be there. Then from U to V, I use the special edge that is there. Okay, and then from U to B, there's a graph, and I try to reach it optimally. So basically, V will tell me what, that starting from A, what is the minimum cost for reaching V. Okay, plus the cost of this special edge, plus dBu will tell me what, this particular part will tell me that okay, if I'm starting the Dijkstra from B, so what is the minimum cost in order to reach the node U. Is that clear? So this is the possibility. So either there are two choices: either you don't take any special cell, and in that case the cost will be what, the cost will be nothing but the Dijkstra algorithm in order to start from A and reaching the node B. Okay, in this particular weighted graph. Or I can take one special curved edge. So if I'm taking one special curved edge, in that case, either it can be from U to V, or it can be from V to U. So is that clear to all of us? Please tell me, guys. Is this part clear to all of us? If it's clear, please tell me, then I can proceed further also. If this part is clear, then please hit the like button, guys. Okay, is this clear? Please tell me in the chat. And if you're clear, you can hit the like button, everyone. What do you eat for this level of energy? Uh, as of now, nothing. Okay, so I think everyone is clear with this, right? Okay, great. So let's move forward and try to write the code for it. Okay, so I'll be having two Dijkstra, like I'll be running two Dijkstras now. One will be starting from one I will run that, okay, what is the minimum cost in order, one Dijkstra will be starting from A as the source node, another Dijkstra will be starting from B as the source node. Please write two in the chat. Are you clear with this part, everyone? That I'll be running two Dijkstras. Does it make some sense for all of us? Please tell me, guys. Is that clear? All of us are clear with this particular part? Okay, so what I will do is, first of all, I'll be having I'll first of all make the adjacency list, because I've been given these edges. So what I'll do is I will make a adjacency list that will be of pairs, let's say. So I'll say that, okay, adjacency pair int comma int, right? Then adjacency, uh, basically, so it will be for n+1 nodes, let's say, because it is one based index. So I'll be having the adjacency list, and other thing is that I'll be having the curved edge also. So vector, then int, and curved, CUR VD. So I'll be having the curved edges as well. Okay, so what I will do here is I will have int I starts from 0. Okay, and I is lesser than the number of edges dot size. So m has been given. So I plus plus, right? M is the number of edges that I'll be having here. So what I will have is, like, let's say the U will be what, edges of I and 0. Okay, and basically V will be what, V is equal to edges of I1, right? And after that, the weight will be what, the normal weight will be nothing but edges of I2 that will be given. Okay, and the curved weight, like let's say the curved weight, let's say CUWT, curved weight will be what, curved weight will be nothing but edges of I3, right? This is what has been given in the input. So what I will do is, first of all, I will simply say that, okay, in the adjacency list of U, what I will do is I'll push back, uh, in the adjacency list of U, what I will do is I will push back V along with the weight. So I'll push this weight, okay, normal weight. Similarly, what I will do is, in the adjacency list of V, I will do what, I will simply push back nothing but I'll push back nothing but U comma the weight, right? That is what I will do. And after this part has been done, so I also need to have a curved array, right? So basically I have, if you will see, so let me make this as adjacency. So vector of vector int, okay, that seems fine. So basically I will be having this curved adjacency as well now. So what I will do is, inside this curved also I'll push this. So CURVD, which is directed, right? So inside this curved adjacency list, what I will do is basically inside this curved array, what I will push back is I will push back that okay, what is connected? U is connected to V. Okay, and the curved cost for that curved edge, special curved edge, is CWT. Is that clear to everyone till now? What we have done? So from the given data, what we have basically done is we have inserted all this. Right, Devrat Mishra, is that clear to you? Rishit and other people are clear? Please tell me. Is it clear to all of us? Is that clear till now, guys? Everyone is clear? So this is what you will do. First of all, you will make the adjacency list now. Clear till now? Okay, Ram says clear. What about others? So curved edge is directed. It is given. Yes, I will show you. So you can see here na curved the special edges that are there. If you will see, so basically you are given two vertices A, B, and you have to go from this. That is fine. But yeah, so this means that x to y, and there is a straight line and the weight w1, and the curved edge is having the weight w2. Yeah, so it is kind of, you can say, it will be having some direction, so you cannot take that for granted. Basically from u to v it will be given now. Okay, so what you will do is first of all you will apply the Dijkstra from A, correct? So in that case, what we will do is first of all we'll have the vector int, give me a second. So it will be what, vector int, let's say the da will tell me about the distance, the shortest distance from A, right? So in that case, what I will do is, let's say I'll write a function for ourselves that will calculate the Dijkstra, the smallest path using the Dijkstra algorithm. So what I will do is I'll pass A as the starting node, okay, and I'll pass B as the ending node, and then I will pass N and I'll pass the adjacency list. Is that clear, guys? Please tell me. What is clear to all of us till now? Right, so da will tell me what the shortest path for any other node, that if I'm starting from A, right, that is what it will tell me. And similarly, if I have to find it for B, so what will I do? I'll simply say that okay, it will be nothing but vector of int db, and I will call the function in which I'll be applying the Dijkstra algorithm. So I'll pass B as the starting node and A as the ending node. So A will be the ending node, and I'll pass N and I'll pass the adjacency list here, right? So this much point is clear. Once I have it, so initially what I will say is, initially I'll say that if I don't apply any special edge, so without any special edge, what will be the answer? Answer will be nothing but dA, that if I'm applying the Dijkstra from A, so starting from A, what is the minimum cost, what is the shortest path to reach B? Is that clear to everyone? This part is also clear, but we need to check all the curved edges from where we can get minimum answer. Yes, we will check that also, but first of all, this will be the answer. No, after that I will apply the thing that I will tell you. But first of all, without any special edge, this will be the cost. Now, like what will be the cost? The cost from reaching from A to B. So if A is the source node, so starting from A, what is the cost for reaching B? Is this part clear to you, Naikach? Please tell me. Is that clear? I hope that this part is clear, right? Okay, so after this has been okay, so I think this part is clear. So after this has been done, what will you do? So after this has been done, so you will say that okay, I starts from 0, I is lesser than what? I is lesser than the number of curved edges that I'll be having. So I think m I plus plus, and then I will have u is equal to what? I think it will be edges of I0, right? And then v will be what? V will be edges of I1, and then I will have the special curved edge. So let me write it as a special edge will be what? Special weight will be nothing but edges of I3, because I2 will be what? The normal weight. Okay, sorry, I'm iterating through this curved edge now. Give me a second. So CURVED curved. Similarly here also CURVED curved edge. Okay, and here also I will write curved edge. Yeah, so I will be iterating through it. Let me write it properly, curved edge. And then what I will do is I will simply say what? I'll say that okay, the current answer will be what? Like the current answer that I will get, the current cost, let's say the current cost will be what? The current cost will be, like, there are two costs. So let's say I will have cost one. What is the cost one? The cost one is this particular thing. If I have this thing DAU plus DBV plus the special weight. Okay, so it will be nothing but what DAU. Okay, so if I go from A to U, okay, and then I apply the special H, so SPECIAL special weight, right, plus the DBV. So for reaching V. Is that clear, guys? Till now, Naikaj, is that clear? Other people are clear with this? Please let me know, guys. Is that clear? Right. So the cost one will be what? DAU plus the special H plus DBV. Okay. What can be the cost two? So the cost two can be cost two can be nothing but, okay, Ram is clear with this. So this will be what? DBV, sorry, DAV, right? So from A, if I'm trying to reach V, so what is the minimum cost for that? This particular part plus the special H plus DBU. Okay, so plus the special edge that I'm taking, so special curved edge, that cost that I'm taking, plus the db u, that is what I'm doing, right? And what I will say is that answer will always keep on updating with the minimum. So answer is equal to minimum of all the three choices, right? So minimum of what? Answer is equal to minimum of answer that I have stored, comma, this special cost one, comma, cost two. Okay, that is the thing. And then in the end, what I will do is, I since I'm having this answer, so what I will do in the end is, if it happens that the answer, let's say, if in the end the answer is greater than equal to infinity, right? So 1e9, let's say it is greater equal to infinity. In that case, I'll say that, okay, it is not possible, so I'll directly return -1. And otherwise, what I will do is, otherwise I'll simply return this answer. So is this part clear? Then I just need to implement a Dijkstra algorithm. The rest everything we have done. So is this idea clear to everyone? Guys, please let me know. The idea is clear to all of us. If you are clear with the idea, please tell me. Okay, so this is what we'll be doing, and now I need to apply the Dijkstra algorithm. So for that, I think I can have a void function. So if I'm having the void function, so what I have to do here, it will not be the void function, because I have to return the list. That will be the shortest path. So what I can say, vector int, and let's name it as function. And what I'll be having here is, I'll be having the source node. So let's say if I'm having the source node, let's say as int a, then I'm having int b, let's say xy, right? X is the starting and y is the ending node. And then I am having int n, and I'm also having the vector of pair int comma int, that is the adjacency list. Okay, so let me use this adjacency list. Is that clear till now? So I can pass it like this. Is it clear? So after I will be after I have passed this, so what I will do is, first of all, I'll initialize the initial distance. Let's say the distance initially as what? Infinity for all the cells. So for all the n plus 1 cells, I'll initially initialize the distance as something like infinity, that is, let's say, 1e9. Then after this, what I will have is, I'll have a priority queue, that is the min heap. So priority, and q will be there, and I will write it as int comma vector int. This basically the template for min heap. Vector int what? Priority queue of, I think, pairs na, yeah. So pair of, I think, int comma int, right? Then I will have vector of pair int comma vector of pair int comma int, right? And then greater int, right? Greater pair of int comma int, I think, right? So that is what I'll be doing. So yeah, now I will have this priority queue. Now inside this, what I will do is, initially I'll say that, okay, the distance of x will be initially marked as 0, because the starting cell will be at 0 distance now. And what I will do is, inside the priority queue, I'll simply push what? I'll simply push the distance, current distance, as 0, and I'll push this node, starting node, as x. Is that clear to everyone? Guys, please let me know. Is it clear to everyone till now? Okay, you can insert negative elements also. So you can insert negative elements also, so it's working as min heap. No, I am taking minimum, basically I am taking a min heap, because sir, what if dau is infinity, then cost one would become negative. What if dau is infinity, Yeah, so that will be taken care of by the code. You don't need to worry on that. I think that will be taken care of by the code. Okay, because my code was getting accepted, so I don't think that will be an issue. The overflow condition will always be taken care of. Should be less. Should be between greater and pair. Okay, yeah, it should not be a comma. Correct. So this particular thing you are talking about. Correct. So till this much point, everyone is clear, na? Now what I will do is, until and unless the priority queue is not empty, I'll keep on running. So while the priority queue size is greater than zero, till that point of time, I'll keep on running. And what will I do? Let's say I'll get the current guy, that is the front guy. So current guy will be what? Q dot top, right? Peak priority Q dot top, and I'll pop it out of this as well. And what I will say is that what is the current node? So the current node, let's say, will be what? The node will be stored in the second part. So current dot second will be the node. Okay. And for this particular node, I'll iterate through its adjacency list. So I'll say that auto, the child of this current node, will be what? Adjacency of current. So I'll iterate through all the children that are there. So adjacency of current. So I'll iterate through the current node. Sorry, the current nodes adjacency list. And when I'm iterating through the current nodes, I'll say that okay, its connection will be what? Let's say I should name it as IP. That is fine. Okay, so iterator, and the child will be what? The child will be nothing but, if you will see, the child has been stored as the first part in the adjacency list, right? So that will be nothing but I should say it as adjacent IT of zero, right? IT dot first, basically, if I've stored using a pair. So I'll say that IT dot first is the child, and what is the cost, what is the weight of this edge? So the weight of this normal edge is nothing but IT dot second between this particular current guy and the child. Okay. So after this, if it happens that the distance of the child, okay, distance of the child from the source node, if it is greater than the distance of the current node plus the weight of this edge. Okay, if it is greater, then in that case I'll say that okay, I need to update the distance of the current node. Sorry, distance of the child node will get updated because this will be lesser. This particular path will be lesser using the current and the edge, right? So I'll update it as distance of current plus WT. Okay, that is what I will do. And then I'll simply do what? I'll simply push inside the priority queue the distance of this particular node. Okay, so I'll push the distance of this particular child and this particular node also. So I'll push this child node, right? So is this point clear to everyone? That is what I'll do in terms of pushing the pairs inside the priority queue after the traversal is done. And in the end, I will simply return the distance array. So is it clear, guys, to all of you? Please tell me. Is it clear to all of us? If you're clear till now, please, you can hit the like button, guys. I hope I have written the Dijkstra correctly. Line should be adjacency of node. Yeah, adjacency of node. Correct. So should I? Yeah, I should write this as node. Sorry, very sorry. And in that case, I should update this also. No? Node. I have a habit of writing BFS most of the times, right? So that is why I've made this mistake. Okay. I think it should work. Let's see. Let's see what happens. I might get some compilation errors. Okay. So your code is returning this much, whereas they are expecting this much. Okay. So I think I'm making some mistakes somewhere here and there. So let me see where I might be making any mistakes. If you can see where I'm making mistakes, you can tell me. So what I have is I have this. I will zoom in a little bit, right? So I have this X, Y, I have this N also, and I have this pair of adjacency list, right? Now I will initially mark the distances as infinity. That is also fine. Then what I have done is I have declared this particular priority queue, right? So priority queue will be storing the pairs, right? And then I have this pair of int comma int, then I have greater pair int also. Then I have marked the distance initially as 0, that is for the starting node. I have marked the distance as 0. Then I have pushed it also. Then while pq dot size is greater than 0, till that point of time, what I will do is I'll take out the current guy, okay, and this will be nothing but pq dot top. Then I'll pop it out also. Then what have I done? Like, have I made any mistakes here? Because I will get the node, so the node will be what? Current dot second, I think so. Then after that, the child will be IT dot first or not. Yeah. So, and the weight corresponding to that will be it dot second. So if the distance of this child, okay, if it is greater than the distance of this node plus the weight, so in that case the distance of the child will get updated to this thing, and then I'll push the distance of the child along with the child also. So I think that I have not made any mistakes in this part. Like, have I made any mistakes in this part? Okay, I should write this as 2. Sorry. Yeah, I think I should write this as 2. That was a mistake. So curved of I2, that is the mistake, I think. Let me try and compile it now. Let's see what happens. Okay, it is working fine on the sample. So basically, I had made a mistake here. No, I had written curved of I3. Basically, it will be I2 only. Sorry. So now let me try and submit it. Is it clear? Aman is also clear with it. Okay. Let's see how it goes. Okay, it gets accepted. So is this problem clear, guys? Basically, you just needed to understand that either there will be a direct path, right? So one of the cost will be what, like, if I will talk about the basic ways. So one of the ways is that if I have to reach from a to the node b, okay, let's say if I have to reach from a to b, so in that case what I can do is I can simply apply that is from starting from a, what is the minimum cost for reaching b using the Dijkstra algorithm. That is one answer. The second way of doing it could be that if I am at a, okay, then what I can do is inside this graph I can follow some path, okay, in order to reach the node u, and from u I can take this special edge u to v, okay, and then I have from v also I have a internal graph, right, such that I can reach b. So basically in such a case, what will be the cost? The cost will be nothing but dau, that is the minimum cost for reaching u if I'm starting from a, okay, plus the special edge, right, plus the special edge here, plus nothing but what, plus dbv, that is the minimum cost for reaching this node v if I'm starting from b. Okay, that is the other scenario. And the very third scenario that I can have is that if I have a, so what I can do is I can reach the node v, okay, then I can have this special edge u to v, like this, okay, and then I can have some path, and then I can reach b. So basically the cost for that will be nothing but dav, that is the minimum cost to reach the node v if I'm starting from a, right, plus the special weight that I am having, right, and plus the db, that is the minimum cost to reach this node u if I'm starting the Dijkstra from d. So that is the thing, and after applying all the possibilities I will get this thing. So that is why I have to calculate the Dijkstra starting from a also and b also. Is it clear to all of you? Please tell me, guys. If this is clear, please hit the like button, guys. Is it clear to all of you? Now talking about the time complexity, the time complexity will be nothing but the time complexity of the Dijkstra algorithm. So I think it will be v log e. Let's check that. Yeah, so you can check, you can see that basically it's kind of n plus m log n. So basically it is nothing but the time complexity that is taken by the Dijkstra algorithm only. So is it clear to everyone, guys? Please let me know. And previously this question was asked in nothing but Uber. Okay, so Uber has asked this particular question. I hope that everyone is clear with it. Is everyone clear? You can give me a +1 if all of you are clear, right? And what I will do is I will just share this code also. Just give me a second. Somehow I have to share this code. So what can I do? I will copy this code from somewhere here. Okay. Now let me click on the GFG ID. Okay, Ram Goel is clear. Thanks a lot, Ram. Let me try and fetch the code from here. Thanks, Saman. So let me share this code with all of you. Does index 3 exist? No, it did not exist. It was not existing. That was the mistake that I was making. So that is why here you can see now, after that what I've done is I've done this particular thing. Special will be nothing but curved of I2. Very funny, did not get segmentation error. I think why did not get segmentation error, because I had not defined the size or something, but it should have given a segmentation error, but I don't know why. Something wrong with the GFG compiler. Okay, but it should have given, but it did not give, so that's fine. Is it clear to everyone? Okay, I hope that the problem was clear to everyone. Very funny. Yeah, so that was it for today, guys. I hope that you enjoyed this particular problem. This problem was just based on the concept of Dijkstra algorithm, but you can write easy in the chat or medium in the chat if you think that this problem was not that hard, right? I believe that this problem was not that hard, and the reason why I recommend solving the problem of the day is because you get to solve such kind of problems which have been asked in companies like Uber. So if you will solve the problem of the day regularly, so you will get in touch with such kind of problems, right? So with that being said, thanks a lot for joining. I'll see you on another with another problem of the day on Monday. Thanks a lot and keep coding, guys. Make sure to put in the effort. Make sure to upgrade yourself, upskill yourself. Keep on increasing your problem solving skills. And I'll see you on Monday. Till then, good night and take care. Thank you, everyone.